Hello friends, I am Mrs. P. Kaur. I am working in robotics, having experience of near about 15 years in industrial line as an electronics engineer. I am going to start a basic level course for the students from 7 years old to 70 years old. For those students who do not know even ABC of electronics, right? So I have made slides to learn step by step. So first of all, what is robotics? Okay, robotics is a branch of science focused on learning about and creating robots or machinery that can do work, right? Why robotics is important? Because nowadays robots are used in industrial purpose, doctors to help in surgeries, in the manufacturing line, in the assembling line, in the packing line, in the transport system, in the earth and space exploration, drones for taking the photographs from anywhere. So many branches are there for working in the robots, right? Who create the robots? Engineers, computer scientists, mathematician, me, and of course you, the hobbyist, create the robots, right? How robots work? Give instructions through switches or through programming, it will work accordingly. They gather the information from sensors or switches, process the input accordingly, perform the desired action. Basically, robots have two parts, right? One is software, one is hardware. Suppose you have to create a robot to deliver the medicines to the patient without human. What will you do? For this, you have to collect the information from the sensor, right? Or the switches, feed the input for the direction through programming. The motors and robot will work accordingly. So for this, you should know the basic electronics at least. And for basic electronics, different parts are there, right? Like resistances, capacitors, switches, relays, connectors, and power supplies, batteries. Okay. So today we will learn about the resistances. What are the resistances? Resistances resist the flow of current. Unit of resistance is ohms. We can measure the resistance either with this multimeter or with the color bar it is having on it, right? So each color is having one color, and to remember that I have made one page that is BB Roy, Great Britain, very good five. Here B is for black color has zero value. Other B is the brown color has one value, and then red. R is for red, then two value. O is for orange, three value. Y is for yellow, four value. Great. G is green for five value. Britain blue is six value, and then very means violet is seven value. Gray is eight value. Then nine is nine value. So each resistance has four bars, right? Four bands. First band, second band, and third band, and fourth band. You know the colors of each band. Like first color will come in the unit place, second will come in the tens place, and third will come in the 10 raised to power, means how many zeros are there. Third color will come in that place. And the fourth band will show the accuracy. Right. Suppose one resistance is of brown, red, and green. Brown color is one value, and red is two value, and green is 10 raised to the power 5. The green will come in the third place where how many zeros are there. So accuracy is the fourth color. Suppose silver color is there, then that means 10% accuracy, and gold color is there, 5% accuracy. Brown color is there, 1% accuracy. So each color has accuracy. Some colors like golden, silver, and red all colors have accuracy value. Suppose I have given you in the slide one resistance that has color brown, black and orange. What does it mean? Brown has one value, other 0 will come in the tens place, other orange will come into 10 raised to power 3. Means brown, black, orange means 10k resistance, right? So in this way we can find the value of resistance. Resistances can be used either in series or in parallel. In series, they will add like 100 ohms, two resistances are there. When you will connect in series, they will come as a 200 ohms. Suppose 100 ohms and 100 ohms you connect in the parallel, its value will be just half, means 50 ohms only. So there is one formula in parallel, 1 by R is equal to 1 by R1 plus 1 by R2. Like this we can connect the resultant resistance value. So what is the wattage of the resistance? Resistance wattage is also important. Generally resistance we use in the 5-volt supply for the Arduino is a quarter watt resistance, where the low resistance is there, then the wattage will be very high. So resistance wattage is quarter watt, half watt, 1 watt, 2 watt, 5 watt and so on. So many exercises, I have given 2 or 3 exercises to remember the resistance, how to calculate the resistance value. Suppose 3.9 mega ohm resistance is there and 2% accuracy is there. You have to tell me the first color, then second color, then third color and the fourth color. In the same way, 680 ohm resistance with 1% accuracy is there. Then you have to tell me first color, then second color, and third color, and fourth. And so I have given you one full exercise. Answer I have given in the next sheet, right? And again, one more example I have given you, 3M65 ohm resistance with 5% accuracy. You have to tell me the band's color. Answer I have given in the next sheet. Again, in some resistances, coded values are there, like 103. 103 means 10 into 10 to the power 3, 10k resistance. Like this, I have given to 5 values and you have to tell me the value of the resistance. In the next sheet, I have given you the answer.
It is the continuation of the resistance. Two types of resistances are there. One is fixed, one is variable. Suppose 100k fixed resistance is there, that means it will give value of 100k, right? But suppose it is a variable like this potentiometer, so it can give the value from 0k to 100k. I have used this potentiometer or variable resistance in my traffic signal circuit. To reduce the time interval of the lights, I have to increase the resistance. So, and to decrease the time interval of the light, I have to increase the resistance. Like this, now using the resistance, you see the interval will be less. Now I have increased the resistance value, so the time interval is less. Now it is reduced. So this is what about the potentiometer or variable resistances. There are some natural components whose resistance vary with the light. The most common example is LDR, light depending resistance. This LDR you can use as a sensor in different circuits. You can use this LDR to switch on or off anything with the variation of the light. Here I am using this in a small project of street light. If I do the darkness with this black paper, this light will switch on. Now I am removing this. See? So this is the main property of the main characteristic of the LDR.
Thank you very much.